Welcome back to Wanky Designs. I'm James, and today we are going to be discussing all things wood lathe with the treadmill speed control, fans, emergency stops, and cool name tags. Let's get started. Okay, so in the background of the magical world of YouTube and Instagram, I've been kind of working a little bit more on the lathe, getting a few more, non-essential video recorded bits and bobs done. One of which is this extractor weird looking pipe that's coming out there, which we'll get onto shortly. The main topic of discussion today is we're going to be wiring in one of these magical boxes. So it's a DC 51. I think it's DLM speed control. Here's a picture of it on somewhere like eBay or Banggood. This came in the post. I've got one in the previous electrical cabinet, but it kind of got a little bit chewed up and I had to modify it for it to fit into this box here. So we're going to tidy everything up and mount everything onto here. So let's look through what we're going to be doing with this episode. Okay, so with everything that, Corona kind of happened when I first started this project, I knew I'd want to be changing this, and I already have an emergency stop button. I think that is very important to have on here, especially something like a wood lathe. It's not like a metal lathe. It's it's cutting bits of tree carcass. It's still a very, very spinny thing that's going to fly into your face. So I wanted this to be right. I'm going to have this lathe for a number of years, hopefully. So I may as well, do it right. I don't want to kind of revisit it. So I bought all the electronics I thought I would possibly need, and I can't kind of see anything that I think I will need so far. I've already got the nice machinist lamp in the background. I bought a fan because this is now a lot more enclosed than the previous lathe was a direct drive. So I'm going to keep an eye on the temperature. I'll be putting a probe on there just to keep an eye on the temperature through various cycles. But the main thing today is showing you guys how to wire up a treadmill motor onto your lathe with the benefit of a speed controller. I do have to give a disclosure, anything on this video you should not copy or do stupid things or eat crayons. If you are not a very clever person, don't do this yourself. Get someone with a brain to do it. It is very simple, but if you've never done something like this before, we are talking about electricity, spinny things and things that set on fire. So if you are from Liverpool, then don't tackle this. This is definitely not a job for Liverpudlians. So let's get started, and first off, let's talk about the panel. Okay, so putting this in, what I'm going to do is just give you a few little tips, and then I'm just going to kind of get on with it. Typically, I wouldn't put this on here and then try scribe round it because it'll look horrific. I would work out your offset with something like a combination square. I would work out roughly where it's going to go, and then from that point there I would add on that distance and then just scribe down this point here, and that's going to avoid it looking pretty terrible. I've seen loads of people put them in and draw around it, and then I have to get it's not good. It's not good. I'm going to be using one of these, which is called a multi-tool. I've always called them a fein tool, and I was very I got Instagrammed and got shouted at by a few people. So it is a multi-tool, I know, but I've always just called it a fein tool. So it makes a lot of noise. It's currently about 7 o'clock, so I'm pushing my limits here, but I kind of need to get it done. But they are very good. If not, you can always draw this, outline it, draw 4 circles here, 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 and here. And then you could use something like a coping saw. You could use one of them weird drill bits that I've never actually used that's meant to go around corners that look like one of these. I don't know how terrible they are. You could use a hole saw, 2 big hole saws, and then kind of rasp it into shape. There's loads of ways to skin a cat. I've got a multi-tool, sorry. So I'm going to use it. And that's it. So yeah, let's just do it. Okay, let's carry on. Yeah, it's about 7:30 now in the evening, and this is really loud, like mental loud. And you know, you're using a tool and it's that loud that you feel guilty using it, and yeah, if it's in the daytime, then yeah, I should probably do that. So I'm going to stop and go to bed. So I will see you in the morrow, is what I'll do. But before then, I'll just show you briefly the dust extraction idea that I've got. Let's have a quick look at that just before we go. This pipe that you can see here goes to the back of the lathe. So this cabinet here, we built the box and we put it just slightly offset. And the reasoning behind it is that my plans are to use a dust extraction system that's cheap and very, very easy to install. So this is going to be the outfeed, if you like. The infeed is going to be here, and I'm using this 40mm plumbing stuff, so when the lathe is on, and depending on the diameter that you're actually turning, is that if I had two hands, this is movable. So you can kind of, it's moving as I play with it, but you can kind of move this and change out this little section here. So if you're doing something pretty big, you can move it round. If I was to then use the bowl turning attachment, I've then got another pipe, so I can just turn that, and I'll have another one pointing this side, but well, it'll probably be about there. But that's kind of how it sits. Yeah, the plywood board was one of the shelves that I've used, but it doesn't matter, you're not going to be able to see it. So if you are going to be mounting something like this, it's always a good thought to what's this going to go, you know, behind. There were some two little brackets here and here. I have cut those off, and now this is going to sit up flat against that minging looking wall. Minging looking wall. Look at that wall. Look at it. We are just kind of filling in the time here before we go to bed, because I really don't want to go back. I'm enjoying playing in the shed. This is the tag that I had made, so my Instagram followers on here will be familiar with this, but this is 0.9 material and it's 305 stainless steel, and this is the part that we actually made in the CAD video. If you're not into your CAD stuff, then yeah, you don't need to watch that. It was for a friend. But this is the same copy, so if I move this over here and here, I should be able to put in the picture. But it is a pretty good fit up to how the original one was. Cost-wise, was a lot less than what the transfer was, put it that way. But to get something like this made, if you're quite friendly with the local laser cutting shop, you're probably talking about 20 quid for, you know, something like this. I got 3 of them made. Often these laser cutting places have minimum order charges, so it is unlikely. A lot of the places do now, because obviously people like me go in there saying, can I have this little bit of, you know, epoxy metal, but even so, it doesn't cost a great deal. Instead of getting the transfer remade, it's not great, but this is what the budget's kind of got me so far. And I'm not quite sure how to mount it yet, but for finishing it off, or at least for semi-finishing it off, I am delighted with that. Really pleased. In the last video as well, just in case you did notice it, or you are thinking about having something like this made, obviously you've got to think of how is this manufacturable, and these parts here, obviously if you just draw around those tags, these two, which we're going to call islands, would be islands and not connected to it. So how I was always taught when drawing in CAD is that any islands that you want, you need to connect them with you know, these little bridges. So you need to make bridges in all your parts. It's a good little way of thinking. I hope you did notice as well, just for this video, that I was wearing a matching coloured polo shirt. No, not really. But anyway, I'm going to see you tomorrow, and then we can make some more noise and hopefully start turning bits and bobs around on this. And I've also got a upcoming future project that you may be interested in. So stick around for that, and we'll see you tomorrow. And happy Easter.
The next day.
Good morning. It's the next day. I have made more noise. I have whole sawed a few things. That is a word. And we're looking good. Well, this is, I'm not. I feel horrendous. I can't get my hair cut. So I'm not going to shave my beard. I'm not going to wash. No, I did. I had a shower. Okay, so we have emergency. Nothing's, you know, all in secure as of yet. I decided to put in the tachometer because it kind of balanced the panel out. I know that sounds a little bit OTT, but everything is in now, and I think is looking pretty smart. So now we're going to try and do a bit of a close up on here. It might be a little bit dark, but I will do my best. But everything kind of works. The problem with this is that when you record... Okay, I won't lie to you, I'm trying my absolute best to get the best footage of this as I possibly can. But my hands are that big, I kind of can't get in anywhere. So I do apologise in advance, but when the time-lapse and bits and bobs are over, then I will give you a bit more of a closer up. My hands are in the way on everything. I've tried all different angles. I've tried putting the camera everywhere, and yeah, I'm kind of struggling to do it. So I'm going to have to kind of do a bit of a after shot after, and then kind of go from there, to be honest, because I am admittedly struggling a little bit with, yeah. A little while, but the exciting thing is, I'll give you a few different shots of this. Everything is lighting up and working, and speed controller check. Top speed. Kind of where we're at the minute. Exciting. Okay, so this is kind of where I've got to so far. There's a few little bits and bobs that I need to point out. Now, this is live. I'm not going to put my face or my piggies anywhere near anything. I'm just going to point out a few little points and give you a few shots. Under no circumstances should you be inside of an electrical cabinet whilst it's not closed and it's powered on. You know the score. You know the score. So, what we have is obviously our motor is running on here with our pulley that connects to our line shaft or main shaft onto the lathe. We have this tachometer sensor here that I'll get into because it's a little bit untidy at the moment. We have the body of the speed controller here. I'll give you some close-ups. I had a little bit of an issue with a earth leak previously, but I've connected the earth directly onto where the earth has been on the motor on the side here. I have got a little machinist lamp that is going to be bolted onto the side here. So I've used a chocolate block for that reason. And you'll notice as well that these have got the red connectors on the side, you eagle-eye watchers wherever you are. They are the incorrect ones for this thickness of cable, but the only ones that could fit on this. Why am I using this size cable? Because it's the only cable I have and we're in the coronavirus, but it has done the job okay so far. Everything is strapped down as best I can with using these, which are called P-clips, which are just screwed down into the base here. The next little bit of a problem that I have had is the sensor on here just works off from a magnet rotating. Temporarily, this is on a magnet on a tie wrap. As you can see here, that's going to be flinging round. We're running at 500-ish RPM, so it's not too dangerous at the minute. If anybody could let me know what the maximum rotation speed of a Pound World tie wrap, please do let me know. Let's shut that off. But it is working as it should. Admittedly, there are going to be many experts out there, and they're going to tell me how I should have done this, etc. This is pretty much where it's going to be. Everything is safe, everything's going to be enclosed. This is bolted down to the frame of the bed. It is earthed correctly in my opinion. It is the emergency switch is wired correctly. It's just this. Now the problem that I mentioned earlier, so this runs off a 12 volt supply. And these sensors, these cables go into the back of the LED control panel here, and it works off one of these DC power supplies. I have looked inside of this, and I can't see anywhere that I can kind of knock onto it that's going to have a stable DC. Obviously, if I'm going to be kicking out, I think this motor's around 200, maybe 300, 400 watts. I can't see what the maximum is, and it's not on that sticker, and I don't really want to blow up my screen. So I'm kind of not sure. Originally how I set this up is that this just had it can run, I think, between 6 and 12 volts. So I had a 9 volt battery that just plugged into here on the side. I kind of don't want to do that. I kind of want to, switch everything on and it works. And then when I press the emergency stop, I want this to stop. So I'm kind of not sure what the best way of me doing this. There are people who have taken these plugs apart to do it that way. I kind of, I can't take it apart and I don't really want to do that, and I kind of don't want two plugs. So I'm not sure on that front at the moment. I might just leave this in the side and continue with a 9 volt battery because that's done its job for a long time. This is unplugged, by the way. So I am not sure. If you have any suggestions, there is something that is available, and obviously there will be a standardized box that will fit in here that will just convert. One thing I did think is inside LED lights, the strips that you get, is you get the what do you call it, the transformer or inverter, the little inverter boxes that go on from a obviously an LED light down to one of these, and it's just like the little push fit things. I can't get hold of one of those, and I don't have one of those. So I don't know. I don't know. But it does work.
A few inches later.
Okay, so I thought I'd just give you a few more close-ups and what I've kind of done. So, my spotlight is my torch. On here, as you can see, these have to be really close, and this took me quite a while to actually figure out, accidentally, that you can see the tolerance here is probably about 0.2 of a millimetre. So you need to get that really, really close for that actual sensor to work. I'm going to trial this because it does seem to work and it is pretty solid. That is a bit crap, admittedly. The ideal situation would be is to mount this at the rear, and there should be another plate that goes onto the back of this, and you would mount that a lot more safer this way. Arguably, if I did have a plate here, the electrics could be, you know, run the risk if this flies off and hits something. Not particularly great. And this is kind of on a pivoting adjustable base that I've put in. So this was one of the hole saw cores that I had, and this can actually move in and out left to right, but it's still very, very nice and solid. The temporarily, what I've done, I'm just going to move it, is the infeed, the DC infeed for the, I keep wanting to call it proximity, so it's not, it's a tachometer sensor on here. I have provisionally, temporarily bodged it to go into here, to then run another supply onto here, because I need to get this working. I'm going to move you again, hold on. Hope you can see that okay. The emergency switch, the cut off, whatever you want to call it, emergency stop is here, and you have to break the Lathe effectively. So this is a on-off switch that goes, it's not on, nope, we're not on, which is going to go to the straight of the positive of the speed controller itself. I've still got the torch to do, sorry, the machinist lamp to do on here. I've used these crimps many times, and they're all pretty crap and not particularly very good, but they do a job. So this is kind of this area done. As I say earlier, the earth is done onto the Meteor. This bag here, you may be thinking, what the hell is that? This is the old speed control that I've had, and it is securely, I'm hoping it's not going to vibrate and make too much of a noise, but I've put this in here because it has a fuse, it has a replacement switch, it has replacement connectors, it has some, bits and bobs on here that I might need in the future. This is a working unit, but for me it's not safe to use, so this is going to be for the parts. Instead of having this in a drawer somewhere, I will have no idea where to find it as soon as I put it in that drawer, so I'm going to keep it with the other control here, and this is also a good way of looking at this if I am working on this, if this makes sense. So I might use this in a future video, but all it's going to take is 4 screws, lift up the lathe and take this out. I do predict that the weak point on this is going to be the emergency stop switch. These always break, but they're a cheap enough component to break, so that's probably going to be the weakest link here. But apart from everything else, it's kind of bomb-proof. They're not complicated. This is, if you were to buy a wood lathe from Axminster or something like that, to have this on here, these are really cheap to manufacture motors. They're not complicated by any means, but this is kind of the expensive bit. But you can buy these. There's a few UK eBay sellers that are selling these quite cheap with a speed controller already in. I actually bought a treadmill, ripped it all apart, took out the control board to keep some of the bits, and this is the spindle mounting, which again took a long time to get here, but for me this is the most securest way of actually bolting this down and for the motor to be secure. So yeah, that's kind of everything on here. On the front, again, we've fitted everything properly. These, everything does fit nice, nothing's loose and a bit tacky. So yeah, I think it looks kind of good, and we're going to fix it all on and get started. that's going to be a wrap for this episode. Thank you so much for watching. The lathe turned out great. Everything is working. I'm super pleased with it. In the next project, we're going to put it to work. We spent all this time getting it going. Thank you so much for watching. Really do appreciate it. For my next project, we need some tools for said wood lathe, and I've bought myself some carbide inserts. So we are going to make our own carbide wood tool. This will involve the milling machine, some machining operations, and then we will put it on the wood lathe and start turning some tree. So make sure to hit that subscribe, give me a like, and I look forward to see you in the next one. Thanks, guys.